We will work on the following work problem. Say we have a tank with brine solution and it has 500 liter of brine initial concentration is 0.02 kilograms per liter. Now we have fluid which is pouring into the tank and fluid pouring out of the tank. It's pouring out of the tank at the rate 12 liters per minute, and it's pouring into the tank at the rate 12 liters per minute. When it's pouring into the tank, it can potentially be poured out from pipe A or pipe B, and we have a switch. In pipe A, we have concentration 0.04 kilograms per liter, and if it's pouring from pipe B, it has concentration 0.06 kilograms per liter. For the first 10 minutes, switch for pipe A is open. Then it switches to B. Our question is find the concentration of salt in the tank as a function of time. Alright. So let's set up differential equation. So we're going to use Ex for the amount of salt in the tank in kilograms. We're going to be using T for time in minutes. And then we have dx, derivative of x with respect to t, equals to input, how much salt is coming in, minus how much salt is leaving, minus output. Right. Let's figure out what is output. We have 12 liters leaving the tank. So how much is leaving? So 12 liters times concentration. Concentration is, we have X amount of salt in 500 liters. So 12 times X over 500, that's our output. Input. It's going to be defined by cases. For the first 10 minutes, we have A is open and concentration is in A is 0.04 and 12 liters coming from A, so 12 times 0.04. After first initial 10 minutes, B opens and concentration B is 0.06 and we have 12 liters coming from B, so we have 12 times 0.06, so we get input equals 0.48 window between 0 and 10 plus 0.72 step function t minus 10. 0.48 window between 0 and 10 is u of t minus 0 minus u of t minus 10 plus 0.72 u of t minus 10. We'll simplify that expression a little bit by distributing 0.48 minus 0.48 u of t minus 10 plus 0.72 u of t minus 10. Combine like terms, so we're going to get 0.48 u of t plus 0.24 u of t minus 10, and that is our input. So we get our input. So we are ready to write down differential equation. So we have dx dt equals input 0.4 u of t plus 0.24 u of t minus 10 minus output 12x over 500. So that is our differential equation to solve. We're going to solve this differential equation by Laplace transforms. So before we do that, let's rewrite the expression as dx dt plus 12x over 500 equals 0.48 ut plus 0.24 u of t minus 10. Now we'll take Laplace transform both sides. So we have Laplace of dx dt plus 12 over 500 Laplace of x equals 0.48 Laplace of u of t plus 0.24 Laplace of u of t minus 10. Recall how to find Laplace transform of derivative. So we're going to get s Laplace of x minus x of 0 plus 12 over 500 Laplace of x equals 0.48. Laplace transform of u to the t is 1 over s plus 0.24. Laplace transform of u to the t minus 10 is e to the negative 10s over s. Let's recall what is x of 0. Our initial concentration is 0.02, so x of 0 equals 500 times 0.02, so x of 0 equals to 10. So we're going to be using x of 0 equals to 10. I'm going to substitute. So we're going to add 10 to both sides. So we're going 10 plus 0.481 over s plus 0.24 e to the negative 10 s over s equals. On the left side we have these two guys left. So what we can do to them is we can factor Laplace of x out, and we're going to get s plus 12 over 500. I will reduce 12 over 500 and I will going to write down L of x times s plus 3 over 125. So I'm going to divide top and bottom by 4 equals 10 plus 0.8 times 1 over s plus 0.24 e to the negative 10s over s. Now to find Laplace of x, we're going to divide both sides by its coefficient. So equal 10 over s plus 3 over 125 plus 0.48 1 over s plus 3 over 125 plus 0.24 e to the negative 10s over s times s plus 3 over 125. Now to find x, we take Laplace inverse of both sides, so we're going to get Laplace inverse of n over s plus 3 over 125 plus 0.48 Laplace inverse of 1 over s plus 3 over 125 plus 0.24 Laplace inverse of e to the negative 10s s times s plus 3 over 125. Let's do fractional decomposition. So 1 over s times s plus 3 over 125 equals a over s plus b over s plus 3 over 125. So we're going to get 1 equals a times s plus 3 over 125 plus b times s. So we're going to substitute s equals to 0. We're going to get 1 equals a times 3 over 125. So we're going to get 125 over 3 equals to a. We're going to substitute s equals to negative 3 over 125. So then that term disappears, so we're going to get 1 equals b times negative 3 over 125. So we're going to get b equals negative 125 over 3. And now if I want to take Laplace inverse of 1 over s times s plus 3 over 125, that is Laplace inverse of 125 over 3 divided by s minus 125 divided by 3 over s plus 3 over 125. So that is going to be equal to 125 over 3 minus 125 over 3. Laplace inverse of this one is e to the negative 3 over 125 t. Right? So we're going to be using this Laplace inverse to finish our problem. Okay, so that's the information which is good. Laplace inverse of that function equals 125 over 3 minus 125 over 3 e to the negative 3 over 125t, and you recall what x equals to. So Laplace inverse of the first expression should not be too difficult to find, so 10 times e to the negative 3 over 125t plus 0.48 Laplace inverse of that expression, we just found it out, 125 over 3 minus e to the negative 3t over 125 plus 0.24. That is essentially the shift by t minus 10, shift in t. So we have u of t minus 10 times, so multiplying this one by 125 over 3 minus 125 over 3 e to the negative 3 over 125, and we need to shift along t by 10. X equals to 10 e to the negative 3t over 125. If we, this guy also should be multiplied by 125 over 3. So here. So if I bring 0.48 inside and multiply it, when I'm going to get plus 0.48 times 125 over 3 is 20. minus 20 e to a negative 3t over 125 plus 0.24 times 0.125 over 3 is 10. So we're going to get 10 u t minus 10, 1 minus e to a negative 3 over 125 times t minus 10. So we get expression for x. Now recall what was our original equation. Our original equation was find the concentration. To find the concentration, we divide amount of salt by the amount of fluid we have. So concentration equals to x amount of salt divided by amount of fluid 500, and we know expression for x. So we take that expression, divide by 500. So 20 over 500 is 0.04. Combine like terms before we do that. So we're going to get negative 0.02 e to the negative 3t over 125. 10 over 500 is going to be 0.02 u t minus 10. 1 minus e to negative 3 over 125 t minus 10, and that's going to be our final answer for this problem.